ASK or amplitude shift keying. Here, the way of digital modulation, two binary values are represented, that is may be 0 or 1, they are represented by different amplitudes of the carrier frequencies. What is the amplitude? Amplitude is the distance from the base level, how high the trough is or the crest is. So the amplitude for 0 can be like this, and for 1 it can be like this. So the change in amplitude will reference different bits, different binary values. Okay. So changing the amplitude, we can represent different binary values. Okay. The problem here is in ASK, it is quite susceptible to noise, and people regard it as not that efficient modulation technique. And this is used for up to 1200 bit per second on the voice grade lines, that is the telephone lines called, and very high speeds over optical fiber. ASK. Let me tell you more about this. This is your bit stream. The main idea, we are trying to modulate. We are changing these bits to signals. So this is the carrier wave. It has a frequency, it has an amplitude, it has a phase. So how to represent it using the amplitude? So wherever you see 1 here, only that will be output. Wherever you are seeing here, there will be no amplitude. You can say amplitude is 0. You can even reduce the amplitude, that can be done. But here you see no amplitude. In everywhere 1 you see, you will see the same wave. 0, you will not see any wave. That is the amplitude will decide. This is the amplitude shift keying. So in amplitude shift keying, two different amplitudes are used to represent 0 and 1. More than 2 levels can be used to encode multiple bits also per symbol. For example, in one symbol you can send 0, 0. You can send 0, 1, 0 like this. FSK or frequency shift keying. FSK. This is also a digital modulation technique. So here we have carrier wave, and the frequency of the carrier signal or wave is varied or changed to represent binary 1 or 0. One frequency will show 1, the different frequency will show 0. Both peak amplitude and the phase will remain constant. Only we are talking about frequency changes here. The frequency of the signal during each bit duration will be constant. It may represent a 0, it may represent a 1. Frequency is what? Number of oscillations per second. For example, this is the range. Now I can make a wave like this. In the same range, I can show the wave like this. So one is having the low frequency, the other one is having a high frequency. So one may represent say 0, the other may represent a 1. Now see here, you have the amplitude and phase are not changed, but when you have a 1, the frequency is higher, the number of oscillation or the number of waves are higher. So all these higher frequencies will represent a 1, but when it comes to 0, the frequency is less. It will represent a 0. So the frequency shift keying, 2 or more different tones are used. You can also say frequency or tones. So now you see a picture here. This is again an example. This is a bit stream. Now we have two carrier waves, high frequency carrier wave. This is very high frequency, number of oscillations are higher, and the low frequency carrier wave, number of oscillations per second are less. When you do the FSK, whenever 1 will be shown, high frequency will be shown. Whenever 0 is there, the low frequency will be shown or will be sent to the receiver, and that is how it deciphers it. Phase shift keying, PSK. Phase means angle. So when we change the angle of a wave and then represent 0 or 1 bits, binary digits, this is called PSK or phase shift keying. In phase shift keying, the phase of the carrier wave is varied, changed to represent 2 or more different signal elements. Remember, the amplitude and frequency will remain same. If you're talking about binary PSK, we will have only 2 signal elements. One signal element with a phase of 0, angle of 0, The other one will have a phase of 180 degree. Let me show you. This is the Cartesian coordinate system. You are already aware of it. Now a line x-axis, if you make a line on x-axis, that will make an angle 0 with the x-axis. But a line which is opposite to the x-axis will make an angle of 180 degree with the x-axis. So the first one can be made to represent a 0. The second one can be made to represent a 1. So this is a constellation diagram. You'll see it in QAM 16, QAM 64. So bit 0 will have a phase of 0. The receiver, whenever it will have get a phase of 0, will say 0. If it gets a carrier wave with phase 180 degree, it will regard it as 1. So phase shift keying, the carrier wave is shifted 0 or 180 degrees at each symbol period. And because we have two phases here, it is called as BPSK or binary phase shift keying. So binary, we are referring to the two symbols, not that the symbol represents the 2 bits. Okay. So these are PSK and BPSK. But there are better schemes also. There are better scheme like QPSK. First let me tell you about this. Now if you want to send a 1, it is like this. But whenever you want to send a 0, there will be a phase shift. You see there is a phase shift of 180 degree. So this is how 0 will be represented. Again you have a 1 after that. So there will be a phase shift. This is a phase shift. Again you go, but from 1 to 1 there will be no phase shift. Again from 1 to 0 there will be a phase shift. 0 and 180 degree. So this is how 1 and 0 will be represented. So I was telling you about the QPSK. Now again going to the Cartesian coordinate system. So 0 and 180 degree we saw. Now let us make a line here in between. We can represent 4 angles because the waves have different angles, 0 to 360 degree. So you can represent 4 45 degrees from x-axis. This angle is 135 degree. This angle from positive x-axis is 225 and this angle, whole angle, is 315 degree. Now this scheme is QPSK. We are using 4 different angles. That is, these are, one can be used for 0, 0, second can be 0, 1, third can be 1, 0, fourth can be 1, 1. So this QPSK is quadrature phase shift keying that uses the channel bandwidth efficiently to use 4 shifts, 4 angles, 45 degree, 135 degree, 225 degree, 350 degree, and here we are transmitting 2 bits of information per signal. Okay. Binary 2, quadrature 4. In binary we can send only 0, 1. In quadrature we can send 0, 0, 0, 1, 1, 0, 1, 1.